My name is Mark Baumgartner, and on behalf of Dale Green, Jim Bartan, Sandeepa Singh, Julia Rugo, and Colin Ryan, I'd like to present the continued development of Fontis for gear location marking, gear retrieval, lost gear recovery, and enforcement. So most of us are from the Woods Hole Oceanographic Institution, which is an independent, nonprofit marine research, engineering, and education organization. We're a degree granting institution, mostly PhDs through a partnership with the Massachusetts Institute of Technology. We're a large organization, 950 employees. We operate several research vessels and house several national facilities. We focus exclusively on the ocean, and we bring to the on-demand space expertise in things like underwater localization and getting data from the seafloor to shore. And most importantly, none of us have any financial interest or stake in on-demand fishing. So what is Fontis? Fontis is a proposed system specifically designed for on-demand fishing, and it's designed to enable gear location marking, gear retrieval, lost gear recovery, and enforcement. It uses open standards for interoperable communications, and this interoperability is critical to implementing the functionality that I just described. So the components of Fontis, there are three systems: the cloud, fishing vessels, and acoustic devices attached to the ends of trawls, and they communicate with one another. And this is where Fontis's interoperability comes in. We use open standards for communicating between the cloud and vessels via the internet. So vessels are envisioned to have a real-time, full-time internet connection. Open standards are also used to communicate between vessels and devices on the sea floor via acoustic communications. So just to quickly go through the functionality that I just mentioned, Fontis has several ways of doing gear location marking, several ways of localizing the gear, including surface GPS marking, and then two underwater localization methods called ranging and directional ranging. If you don't know what those are, that's fine. I gave a Ropeless Consortium webinar not too long ago entitled The Fundamentals of Underwater Localization for On-Demand Fishing. It's an hour-long recording that you can access at ropeless.org/webinars. So Fontis can use any of these localization methods or a combination of them. And the cloud's really important here. The localization information is collected automatically by vessels and stored in the cloud. The localization process happens in the cloud, and then the cloud shares those gear positions out to minimize gear conflict. In terms of gear retrieval and enforcement, Fontis envisions a standardization of the triggering of releases. There's several advantages of that. One is that it allows fishers to have a variety of manufacturers' gear in their inventory, but only a single vessel-based system that can trigger all of them. So you can have a different manufacturer's gear on the seafloor than the manufacturer that made this surface system, and they'll work just fine together. It also allows enforcement to use a single vessel-based system to trigger any manufacturer's release. The enforcement doesn't need to have a manufacturer's surface system in order to, for each type of device that they're trying to release from the seafloor. So gear retrieval is done through authentic communications to be able to both query and release the gear, and that authentication can be done by gear owners, owner-authorized third parties, and enforcement. The authentication information is stored in the cloud and is accessed through permission structures in the cloud. Fontis also allows for the discovery and recovery of lost gear. Any vessel can help identify lost gear through the use of these open standards for acoustic communication. Lost gear discovery occurs automatically. The fisherman does nothing to do it. It's all happening in the background. And ultimately, gear owners are notified of the fact that their lost gear has been discovered through the cloud, through a system of notification on shore. So during 2022 and 2023, we worked to develop Fontis. We developed a report, and that report was released in October 2023, and it's accessible on the ropeless.org website. 3 manufacturers are currently developing Fontis modems: Dell Research, Teledyne Benthos, and Ropeless Systems, based on the open standards. Importantly, Dell Research's implementation of the Fontus modem will be open source. And so any manufacturer that wants to incorporate a Fontus modem can just adopt Dell Research's implementation at no cost because it will be an open source implementation. Those manufacturers, representatives from those manufacturers, as well as this group that's presenting today and developed Fontus, formed the Fontus Working Group in 2024. And we have discussed and finalized the acoustic communication protocol, what we call the transmission waveform for Fontus. And we've discussed and nearly finalized the acoustic message definitions, which I'll share with you in just a minute. And then I've had preliminary discussions with EarthRanger to implement the cloud components of Fontus. So just to show you what we've been working on, we've agreed, the Fontus Working Group has settled on a Fontus waveform. The waveform is just the sounds that the acoustic modem makes to transmit information. I'll just walk through it quickly with the details sort of scrolling on the right. Every Fontus modem will most of the time be sleeping at the sea floor, waiting to be woken up by if a passing vessel wants to communicate with it. So it uses a very low power wake-up circuit that listens very specifically for particular signals, and that's the wake-up signal. Once it receives the wake-up signal, it wakes up the more power-hungry processor to deal with the rest of the message that comes through. The next thing that's sent is a couple of hyperbolic frequency modulated sweeps that allow the modem to measure range rate, that is how fast the vessel is moving towards it. And we need to account for this because moving vessels producing signals will be sort of contaminated by Doppler shift and time dilation. And so we need to account for that. And so these sweeps are designed to help the modem measure those things. And then finally, the actual data message. The data message is very short. It's only 64 bits or 8 bytes of information. We cram a lot into that message, and that message is sent through frequency shift key messaging. Okay, there's only 10 acoustic messages defined for Fontus for the that are sent back up to the ship from the device on the seafloor. The first pair is localization requests and reports. That implements the gear location marking functionality. The lost device request and report, which implements the lost gear discovery functionality. There are release request and report definitions to permit or allow authenticated gear retrieval. Status request and report for authenticated querying of the health status of the device. And then finally, for vendors that want to sort of add in additional features, there's a vendor request report messages designed for authenticated vendor-specific functions. The messages themselves look like this. This is getting really into the weeds of what a standard looks like. So each message is defined, those 64 bits are filled out of what information goes into those 64 bits and how much space or data space those individual fields take up in the message. And those have been defined. I'm just showing here what the localization request and report messages look like, but these are defined for all the messages that I just described. So what comes next? So after development, there'll be benchtop performance assessments and in-water tests for each of the Fontus modem implementations. And then the next exciting sort of waypoint is to do in-water interoperability tests where, say, a Dell Research Fontus modem talks to a Teledyne Benthos Fontus modem. We'd like to then integrate these with existing release mechanisms. While that's happening, the development of the cloud functionality in EarthRanger can be happening, as well as the development of the vessel-based central command unit. This is the sort of the processor that takes care of tasks that happen on the vessel. And finally, we want to do end-to-end demonstration and evaluation of prototype systems. So that's all I have. I want to acknowledge my co-authors again, the members of the Fontus Working Group, our funding sources, and thank you for your attention.